So we completed this test print a few days ago. Not entirely happy with it, but it wasn't bad, and as you'll recall, it's ripped some glass off of the bed. So what we have done is, first of all, we've swapped the bed over, flipped it over, and then lacquered it and levelled that. We've changed the X belt, and I have adjusted all of these ball bearing wheels. Every single one of them has been nipped up just a fraction. I think they were a little bit too loose, including the one on the direct drive extruder. Yeah, so everything's been adjusted, levelled, and we've gone on to print a test piece that I found on the web, which is different to this one. I didn't want to print one of those calibration cubes because they always look just horrible. I'm always expecting something to come out absolutely perfect, so I was quite pleased when I found what I'm going to show you in a minute. In fact, I'll go and grab it now. So this is what I found, and this is what they call a calibration flower. I'm not really sure I like the name very much. You can see it's got orientation marks on there, and because of that nice flat glass bed, we've got a really nice finish on the base of this. I'm going to move over to the PC in a minute and insert the PC video clip to go with this, but basically this is checking absolutely everything. X, Y, skew, using the diagonal measurements. Pretty much every measurement you take on here is either going to be 100mm or 50mm. It's a paid for download. You get this and two other test printable STL files, and you also get a Excel spreadsheet, and you actually measure 3 times and enter all of the measurements into the spreadsheet, and then it will give you the amount of error, percentage of error, or in case of the skew it will give you error in degrees. So very, very pleased with the way this is printed out. Very nicely printed. And what I actually did was I went straight back to Creality Cura default profile, 0.2mm profile. The only setting that has changed from default was the retraction because of this, and my retraction is 0.5, but everything else I put back to the default settings, and it's printed off really, really well. I will go back over to the computer and we will film on there with some text hopefully being recorded, and we'll discuss the results of this test print. So yeah, it definitely needed some tweaks, which I've now done, and hopefully now with this one we can just get on with some printing, and we'll probably do a on-screen video of the Octoprint running on this Raspberry Pi 4. That has really changed things around. That is, a fantastic thing to have, and yeah, I really don't need to go near the printer now apart from when it's time to take one of these off. So yeah, we'll do a separate video on that, and now we're going to move over to the computer. Right, so we are going to have a look at this Vector 3D print that I found online. I'm just going to go to their website. It's, I don't know whether this is appearing, but I don't want it there. So vector3d.co.uk. It's a printer camera calibration and test suite. It's a STL download, obviously. So this is the one that is check-in calibration. You've got a downloadable spreadsheet to enter the results in. And you've got a overhang test and bridging. well, it doesn't matter. I haven't run the other two. What I've run is this one, and I'm just going to have a look at the reality slicer. So that's what we've got. In my case, I think it was about an hour and a half print. I've printed it at standard quality 0.2, and the only thing that I've got different or set up differently to the standard is the 0.5 retraction distance. So yeah, I've just sliced that and printed it off and close that down. If we go back to the instructions that came with this, so you've got a whole load of test points, and you measure each of them. So 9 to 9, that's external, and then 7 to 7, that would be internal. And they're either going to be 100 mil or 50 mil. So 4 to 4 is going to be 50, 3 to 3 is 100. You enter all of them into this spreadsheet that is supplied. It gives you the chance to enter 3 readings from the same piece. So you would start with 1 to 1, and I've measured it 3 times, sort of in the middle and at the top and bottom. And you can see all of the readings go in here, and then you click on the end and it's an average, and you do that for all of the measurements. So you can see in my case all the readings are in green, and there's what it should be here: warnings, severe errors. Well, this is the interesting bit. In my case, I've got an error of only 0.09% in the y-axis and 0.08 in the y-axis. You could correct that if you want. Now, the skew is an interesting one. Mine is only 0.05. So if you imagine making this object 10 times bigger, you're only going to be 0.5 degrees out, which is pretty good. Now, there are ways to enter this into your machine, and it's all explained here, which is very good. Across, where are we? Yeah. So there's what to enter, how to enter it. Marlin, in my case. Unfortunately, you can't send this with GK. You have to alter the firmware. I mean, I'm not going to be bothering to change anything because those measurements, I think, are pretty good. And I doubt there's very much I can tweak that will improve things very much. But if you have got problems, it does explain how to correct them. I do like the way that this is, correctly laid out in the STL file before you slice it. And even if this popped off and you dropped it on the floor, it's got the arrows, so you know exactly which way that is. Obviously, it's important to measure the correct points, otherwise you're going to get it in a mess. But it's all straightforward, all done on this Excel spreadsheet, and I'm very pleased. I'm yet to print off the other 2 pieces that came with it, but I think for a £5, and it was well worth the money. So yeah, that's just a quick look at that. Obviously the links will be in the description, and I would thoroughly recommend that over one of these calibration cubes because they always look messy to me. I was actually quite pleased with the finished look of this, and to find that all the measurements are pretty much bang on was even better. So yeah, it's something I found. I think it's a fairly new thing. The developer's got a few videos on YouTube about it, and obviously his website. But I think for £5 you can't really go too wrong. I know people are used to STL files being free of charge, but someone's had to sit down and design this and do the spreadsheet work and things like that. So very well worth either. So yeah, that is that. I've shown you previously what it looks like, and yeah, hopefully that was helpful. And yeah, we'll carry on with some other videos about Octoprint now, which has been a real big change to my printing. So yeah, back later.